All right, hello everyone. Today is day 6, exponential equations using logs. We're going to start off by doing sort of a comparison here. It says, what is the difference between these two equations? Up to this point in the year, all we've really learned how to solve an exponential equation is by getting common bases and dropping the base. So for example A, we are able to rewrite 100 as 10 squared. And so if I drop those common bases, I can easily solve for x. But in letter B, I can't really rewrite 7 as a base 3. And there is a secondary option. You could put 3 to the 2x in y1, 7 in y2. You could go to your graph and find that intersection point to get the x value. Second trace, choice 5, blinky shows up, and you would hit enter 3 times, 1, 2, 3. And we could get that answer. However, now, instead of having to graph it every single time, we can use logs. Remember, I know we keep emphasizing this, but logs are the inverse of exponential functions. Just like adding undoes subtracting, square rooting undoes squaring, logs undo exponentials. So the first thing you want to do is isolate the exponential function. So if there's something added at the end or multiplied out front, you want to get rid of that first by either dividing or subtracting things to the other side. Once you have it isolated, I'm pretty much going to be using this method, bapping, because we learned that on day 1 of this unit. So I'm going to stick with that. You could technically log both sides and use your log properties, but I'm going to go with the bapping method. All right, so now it says now let's use logs and solve for x. Even though I just showed you the answer in the calculator, I want to show you that it works. So we have not log, 3 to the 2x equals 7. I want to bap this, so I'm going to turn it into a log. So log base 3 of 7 equals 2 to the x. I can type log base 3 of 7 in my calculator using math alpha math. So math alpha math, type in your 3, type in your 7, and then divide that answer by 2. And so if I take this answer in my calculator and I divide it by 2, it's the exact same thing I just got in my calculator when I did the graphing option. So about 0.89 because it says round to the nearest hundredth. So that's what we're really going to be practicing a lot today is bapping. Essentially, we're solving exponential functions, not getting common bases, and like I said, I use the BAP method. So number 1, already isolated, very nice and easy first example. To BAP this, it would be log base 5 of 7 equals x. That can go right into our calculator. Log base 5 of 7 and round to the nearest hundredth. All right, number 2. This is a great example to show us that we have to isolate first. So please don't make that a 14. We have to divide by the 2. Then this would be log base 7 of 9 equals x. Type that in your calculator, log base 7 of 9, again 1.13, 1.13. Another example where we have to do some isolating first, but in this case we add the 50 to the other side. So 62 is what we're setting it equal to. This is a base e. So instead of logging it, we're going to natural log it. So this is going to be natural log. That technically has an invisible base e. You don't have to write the e. Of 62 equals x. Natural log has its own button. It's on the left-hand side. It's right under the log button. It's right here. So natural log of 62, again, round to the nearest hundredth. So that would be 4.13. So 3 very nice, easy first examples. And honestly, it doesn't really get much more complicated than this for this page. So we're just going to kind of keep on keeping on with these until we get to the application questions on the next page. So let's just make sure we practice all of these. So divide, turn it into a log, Remember, the base of the log should always match the base of your exponential. So log base 2 of 5 equals x plus 3. Log base 2, so math alpha math, log base 2 of 5 is about 2.319 dot 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 in my calculator. To finish the solving here, I would subtract 3 to both sides. So I'm just going to kind of keep that value in there, subtract 3 from it, and there's my final result. X would be negative 0.68. Isolate. Here's our friend E again. So let's use natural log. Natural log of the base, which again is E, you don't write it, of 14 equals the power. And pretty much when you're setting these equal, it's going to be equal with the x component because that's kind of why we need logs. You're trying to solve for x, so the x should be what it's equal to, not part of the log. All right, so natural log of 14, let's take 2 away from that answer so we can finish the solving, 0.64. We are flying. Flying, soaring. All right, log. This is isolated already. So log base, answer, power. Woo woo. We can type fractions in there. 4/5, 4 divided by 5, and 1 divided by 3. All right, how about this? Pause your video and try 7 and 8, and I'll just tell you the answers in a minute. So pause the video, try it. All right, hopefully you're back. Here's what your answer should be for number 7, 1.43. And number 8 should be 2.75. Oh, 2.75 equals t. If you didn't get those, come see me in class. All right, so this was actually preparing us for more application-y type of questions, which you'll see on the next page. So we're not able to teach you logs until after we've already done exponential functions and sequences, because what we always referred a geometric sequence to was very similar to an exponential function. So this formula is making a comeback. You might see like PERT making a comeback in this unit. You might see the A equals P 1 plus or minus r to the t formula making a comeback. And now we are able to solve for the exponent portion using logs instead of having to get common bases. That's still a cool option and that's great, but if you want to solve it by logs, you now have another tool for your toolbox. So given the following sequence, 9 to 18, 18 to 36, I notice that this is being multiplied by 2. So if it says write an explicit formula, that's on our reference sheet, that's right over here. The value of the first term is 9, the ratio is multiplying by 2, so our formula would be 9 multiplied by 2 to the n minus 1 power. Now it says that 73,728 is a term in the sequence. Which term is it? So find the value of n. So 73728 equals 9 parentheses 2 to the n minus 1. If this was an example on the other page and it had no context to it, step 1 would be to isolate. So that's what I'm still going to do. I'm going to divide both sides by that 9. That gets me 8192 is equal to 2 to the n minus 1. Now you are still more than welcome to get common bases and drop the base. But if you didn't like the whole guess and check method of that because you're like, oh, 2 to the what power is that big? You know what I mean? We can just use logs now. So we could just type log base 2 of the answer is equal to the power. And we can just type that in our calculator, add 1. So log base 2 of 8192. We get 13 is equal to n minus 1, add the 1 over. That must be the 14th term of the sequence. That easy. So no more guess and check option to it anymore. All right, number 10, another nice application here. A scientist is studying the growth of a population of bacteria. At the beginning of our study, she has 8 bacteria. So at hour 0, she starts with 8. And if it's quadrupling every hour, then in my mind, that means it's multiplying by 4. So then in 1 hour, there'd be 32. Multiply by 4 again, that's 128. Multiply by 4 again, 512. And one more time, 2048. Write an explicit formula for the number of bacteria present after T hours. All right, so when we are doing explicit formulas, we always use the value of the first term, not the 0th term. So I'm going to utilize this relationship here. So 32 is our first term. It is being multiplied by 4. So I would say A sub n is 32. We're multiplying by 4 to the n minus 1. N minus 1. Find the time in hours when the population will reach the following bacteria, 33 million. So that's what we're going to set it equal to, that big number, equal to the 32. We want to isolate. So divide that big number by 32. It still gives us a pretty large result. 1 million something something. And again, you could, in theory, get common bases and drop the base. But now that we know logs, let's utilize our new knowledge. So log base 4 of that 1 million number. And let's solve for n. All right, so we have log base 4, 1048576. Oh, lovely. All right, so that would mean 11 hours it will take for this particular bacteria to get up to that $33 million, not dollar, 33 million population. All right, let's see what the next application question is. I think we're going to go away from sequences. It says, based on Kelley Blue Book, the current value of Jackson's car is $9,200. The car has been depreciating at a rate of 6% per year. If he wants to sell the car when it is worth $5,000, how much longer should he keep the car? Round to the nearest tenth. All right, I did not hear the word compounded at all, so I'm going to utilize this formula. And usually I would say it's 1 plus or minus r, but this word right here is telling me that it's depreciating. So it's going to be just the minus part of the formula, not the plus. So the current value, so currently, like presently, is $9,200. It's been depreciating at 6%, so that's going to be 0.06 for R. And I want to know when the car will get down to 5,000. So this is my after, this is my current amount, and my 0.06 is going to be my R. I don't know T, because that's what we're trying to find, how much longer. All right, so 5,000, we have 9,200, 1 minus 0.06, and we're going to keep that a T up there. Now, on the last two examples, I said, oh, you could get common bases and drop the base if you want to, because I knew that those were going to work out because we are looking for a certain amount of time. In this one, it's telling me nearest tenth, so we're probably not going to have that as an option. So I have to use logs on this question. So 9,200, we still have to do some isolating. So let's see if that's a nice fraction. 5,000 divided by 9,200. I know the decimal is not cute. Let's see if it math fracts though, because that's always easier to type in. Oh, it does. 25 over 46. That's nice. All right, so I'm going to rewrite that. 25 over 46. All I did was I typed this in and I math fracked it. That's all I did. Okay. Equals, all right, and 1 minus 0.06 is 0.94. So equals 0.94 to the t. I am not going to sit here and try and figure out how to rewrite this as a 0.94 and get common bases and drop the base. I'm just going to straight up use logs. Log base 0.94 of the answer equals the power. So log base 0.94 of the answer. There you go. So how much to the nearest tenth? Looks like 9.9 years. How much longer to the year? Yeah, 9.9 years. So roughly 10 years he has to keep the car so that it depreciates to the value that he wants to sell it at. Number 12. Henry wants to deposit $100 into a savings account with 3.4% interest compounded continuously. That's PERT. If he wants that 100 to grow to 500, how long does he need to keep the money in the account? So his initial investment, P, is 100, and he has to wait until after a certain amount of time to get to 500. So 500 is your after amount. 3.4% interest is 0.034 as our rate, and continuously tells me that it's PERT. So A equals P E to the RT. I have the A. I have the P. E is E. That doesn't get replaced with anything. And the rate is 0.034 T. All right, let's solve it. Step 1, isolate. So divide by that 100. 5 equals E to the 0.034 T. All right. Again, we're not going to get common bases, drop the base. We're just going to use logs. And in this case, natural log. Natural log has a base E of 5 equals the 0.034 T. Divide. Divide. All right, let's find out what that is. So natural log of 5 divided by 0.034. That's a long time. You got to keep that in your bank account. 47.3 years, I guess. Wow. You're going to be just to get $400. That's sad. All right, last but not least, just more of like a literal equation here. Everything's in terms of letters. If you wanted to solve and rearrange this equation to solve for x, the first thing you should do is divide by any coefficients on the exponential. Okay, so I divided, so now I have b to the x power is equal to whatever this would have divided out to be. But obviously they're not like variables, so I can't actually divide them. Now I would use logs. Log, the base has to match, so log base b of the answer equals the power, and that's how you would solve for x. Okay, see you next time.